Hello, everyone. My name is Rachel Champagne, and I'm the Marketing Specialist here at Enterprise DB. I'll be your host today for our webinar, What's New in EDB Postgres Platform 11. I'm joined by Mark Linster, Senior Vice President of Product Development, Robert Haas, Vice President and Chief Database Architect, and Dave Page, Vice President and Chief Software Architect of Tools and Installers. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for 1 hour. We expect the presentation to last close to 60 minutes, so if we do not have time for Q&A, we'll follow up afterwards with any attendee whose question wasn't answered. We'll also be sharing the recorded presentation with you all following the webinar. And now, without further ado, here is Mark Linster.
All right, thank you, Rachel. So I will do this presentation together with Dave and Robert. I will start with first, giving you a quick overview of Enterprise DB, what we do, and what the EDB Postgres platform is. Then we'll start diving into what's new in version 11. We number the versions of our platform according to the database server version, and the platform includes many more components than just the database server. And then Robert will focus on Postgres 11 and EDB Advanced Server 11. Dave will talk about Postgres Enterprise Manager. We'll give a quick demo of an interesting new feature in PEM and pgadmin. And then we'll talk about the supported platforms and the dates when they will be available. And we'll hopefully have a little bit of time for Q&A at the end of the presentation. So first, let me start with who is EDB. I promise I won't spend much time on this. But EDB is the world leader in open source based Postgres software and services. We support lots of large enterprises globally in the US and EMEA and in Asia. Founded in 2004, we've been recognized by Gartner and Forrester. We have over 4,000 customers today. Offices are worldwide, and we are one of the leading supporters of the Postgres open source community. As I said, over 4,000 customers. Notable in here is 92 of the Fortune 500 are EDB customers, and over 300 of the Global 2000 are EDB customers. And they're not just using EDB Postgres or Postgres in general for some small departmental applications. These are all very large and very important apps that are being run on Postgres today. These are just some of the customers whose logo we can show that are referenceable customers. Obviously, there's a lot more behind the scenes. If you want to know more, get in touch, please. So one thing that I mentioned is that we've been recognized by Gartner and Forrester for quite a few years. For the last 6 years, since Gartner restarted their Magic Quadrant for operational and relational database management systems, EDB Postgres has been in that Magic Quadrant. What's especially interesting in here is that today, EDB Postgres is the only open source based relational database management system that is in the Gartner Magic Quadrant. And keep in mind, the way to get into the Gartner Magic Quadrant is by showing a completeness of vision, meaning providing all the capabilities that enterprises are looking for and having the ability to execute. So not just have the product, but have the ability to work with customers on a global basis, on a large scale basis, have the support organization, have the right escalation mechanisms, have the right engineering capabilities, have the right roadmap, etc. But EDB is not just thriving on the enterprise side of the business. We invest significantly into the open source world. These are just full-time EDB team members, or a subset of them, that are working on open source projects. It starts with the core team, where we have Bruce and Dave, who is with me on the call today, strategically setting the direction for Postgres as members of the core team. Then we have major contributors and people who, or many of them also have a commit bit, so they can actually, commit code to the Postgres code base, such as Robert and Andres, for example. Then we have other named contributors, not just to the Postgres project, but for example, to the PG admin project, to PG pool, etc. These are just the team members, the EDB team members that are named on the websites of those open source projects. We have a lot more other people who are contributing to those projects. So you have to look at Postgres, at EDB, as being a company that looks after the enterprise and focuses very much on the enterprise needs, but does a lot of that work on the open source side of the house. So let me talk a little bit about the EDB Postgres platform, because really that's the scope of what we're trying to do here. The EDB Postgres platform is focused around the two versions of the database. On the one side, PostgreSQL, and on the other side, EDB Postgres Advanced Server. EDB Postgres Advanced Server completely integrates all features and all capabilities of PostgreSQL, but it adds to that certain enterprise relevant capabilities, such as a resource governor, an improved data loader, better auditing, and very important, Oracle compatible or a native implementation of Oracle compatibility, so that you can run PLSQL packages and other Oracle capabilities on Postgres. It then provides also a number of tools for integration, migration, and management, which are really important if you want to start saving money and migrating off Oracle or other databases and want to get onto Postgres. You need to have migration tools. Postgres does not stand alone. All of our customers use, let's say, Oracle or SQL servers. So integration with the rest of the data world is really important. You can't just have a standalone app. You need to have management apps, because once you start deploying not just one or two or three Postgres systems, you need to have a capability to do management by exception. You need dashboards. You need visual abilities to understand what is happening in your database estate. Then we come down to deployment options. Obviously, today virtualization is probably the most important deployment option, but containerization, deployment in the cloud, and for certain very, very high performance deployments, still bare metal is really important. Support 24/7 with a enterprise standard SLA obviously is part of the game, professional services, and tuning and training. But I won't spend too much more time on that. I'll dive into the database here a little bit. Obviously, community Postgres, you all know it. It's, and I guess I'm biased, the most advanced open source relational database management system. Supports workloads ranging from OLTP to data warehousing. We know today that a large number of our customers, for example, use Postgres for analytical and reporting purposes. Really interesting inside Postgres is the ability to do PostGIS, JSON-B, and lots of other data types all at the same time. Now, let me dive into EDB Postgres Advanced Server a little bit. It integrates everything from PostgreSQL, but it adds, as I said, auditing, better security, database compatibility for Oracle, and then other DBA features such as EDB Loader, which is comparable to the Oracle Loader, and other modules that make a migration off of Oracle much, much easier. If we dive into EDB Postgres Advanced Server a little bit, you can see that what we did are all the items in red in here, that the work that we did on Postgres to extend Postgres to become Postgres Advanced Server actually goes quite far, so that we've added the ability to parse different Oracle types, functions, procedures, queries, packages, etc. We've also added Oracle compatible JDBC, .NET, and other drivers to make sure that applications that were written for Oracle can run against EDB Advanced Server. But even inside the optimizer and planner, we've done things like query hints. The Postgres community believes that the planner knows best. Based on our experience and our customer input, we know that very often the DBA knows better. We've added things like a resource governor to make sure that you can prioritize resource consumption by roles, for example. So we've added quite a few of these capabilities to EDB Postgres Advanced Server to address the needs of our enterprise customers. And last, certainly not least, the Oracle-compatible PLSQL, lots of the packages, especially in the DBMS and UTL series, that make the migration off of Oracle much, much easier. I'm breaking this apart, Postgres and EDB Postgres Advanced Server, because Robert is going to explain the new features in using the same segmentation. And as far as the integration, migration, and management side goes, we have lots of tools to make integration of data easier. Some are change data capture based, for example, EDB Postgres Replication Server. Other use foreign data wrapper technology, such as the EDB Postgres data adapters. When we look at migration, one thing that we are talking about a lot now and is getting a lot of attention is the EDB Postgres Migration Portal. It's a cloud-based service that makes migration from Oracle to EDB Postgres much, much easier and really fast. Just 2 weeks ago, we did a webinar on exactly that topic, showing how you can migrate from Oracle to EDB Postgres literally in minutes for smaller databases. So here's just one picture of what the migration portal looks like. It's very easy to use. It has parsers, error messages, rules that do schema transformations and make the migration from Oracle to EDB Postgres very easy. And then the last is the management tools. Dave will talk more about the EDB Postgres Enterprise Manager and the new features that we have recently made available as part of PEM. But then I will also touch briefly on the failover manager, which is being used by the majority of our customers for high availability, and then backup recovery, where we've created a special tool that is focused on the needs for customers with very large multi-terabyte databases. So Postgres Enterprise Manager is a graphical tool to monitor, manage, and tune large-scale, enterprise-wide Postgres deployments. And you need something like this once you have more than 2 or 3 or 4 Postgres databases, and once these Postgres databases become mission critical. And EDB Failover Manager, it leverages Postgres streaming replication, but puts everything around it to monitor the streaming replication and make sure that in case of a failure, you can quickly fail over, promote a replica to become a new master, and start using that new master to support your application. Postgres Backup and Recovery Tool, we call it BART, that is especially designed to do block level incremental backup. And block level makes sure that for a very large database, instead of spooling the whole database offsite every time we do a backup, we only spool those things offsite that actually have changed, which once you have more than a terabyte of data, is something that significantly enhances the performance of backup and makes it much easier to spool backups daily offsite very, very quickly. Talking about the deployment options, key thing here that I want to call out is EDB Postgres containers, which contain the database, high availability, query routing, the Postgres Enterprise Manager, and backup and recovery. So that's just another way of deploying the EDB Postgres platform. So let's start diving into what's new in the EDB Postgres platform version 11. I will touch briefly on the EDB Failover Manager and backup and recovery. Robert will talk at greater length about the database server, and then Dave will touch on what is new in PEM. So in the EDB Failover Manager, a tool that we've had for over 5 years, it's very widely deployed. Key capabilities that we've added this year, besides compatibility with Postgres 11, is the ability to run EFM without having to use sudo. That's a key capability for many of our large customers, especially in financial services, where they find sudo management in large deployments too difficult. Use of multiple VIPs so that we can support cross-data center failover, and then better scripting hooks or new scripting hooks that support the integration with load balancers. EDB Backup and Recovery, we just released block level incremental backup, which is going to significantly improve the performance for backing up databases that are over 1 terabyte in size. If you have a small database with 50 gigs or so, you can just spool it to disk. It's not a big deal. But once you get into significant database sizes, just doing incremental backups, just like Oracle does it, is really, really important. And here, beta testers reported that they had up to 80% faster backup times. So now I'm going to hand it over to Robert to talk about Postgres 11 and EDB Advanced Server 11. Robert?
Thanks, Mark. What we have here on the slide are the new features which are coming out in PostgreSQL 11 according to the release notes, which are posted on postgresql.org. PostgreSQL 11 has 2 areas where there are a really significant volume of different changes that all contribute to the functionality of the same general area. So the first is partitioning and the second is parallelism. And so I'll go through the individual improvements in those areas in a minute. Skipping over those for now, another big change in PostgreSQL 11 is the addition of stored procedures. Now, many of you may know that stored procedures have been available in EDB Postgres Advanced Server for many, many years now, and that feature is now coming to PostgreSQL as well. So we have done some work to reconcile the implementation that was done in the PostgreSQL community with our implementation, and to make sure that those things work seamlessly together, so that if you use Advanced Server, you will get all of the advantages of both implementations. But if you use PostgreSQL, you will now have this feature available there as well. In addition, PostgreSQL 11 introduces an optional feature for just-in-time compilation of SQL expressions. And this is basically a performance enhancement. If you have an SQL query that involves even relatively simple SQL expressions, such as where A equals 1, but especially if you have more complex expressions, and especially if the queries are longer running, you can see some very significant performance improvements as a result of this feature. And I think that aside from the immediate performance improvements that we can already see as a result of this feature, it's something which is very exciting in terms of seeing PostgreSQL take advantage of some of the cutting edge technology which we have not had fully integrated into the platform before now. Some of you may use window functions for analytics, and if so, you will be interested to learn that there are now more framing options available for those window functions. So some of the queries which the SQL standard says should be supported and which were not previously supported by PostgreSQL now will be supported. And the last major feature I'd like to mention here in PostgreSQL 11 is covering indexes, which allow you to include extra columns in your indexes which cannot be used for searching, but which can be used to pull data out as part of an index-only scan. So for users with very large databases who are relying on index-only scans for performance purposes, you'll want to check out what can be done with this new covering indexes feature. Looking at the partitioning improvements in PostgreSQL 11, there's really been an enormous amount of work that has been done, and there continues to be a large amount of work which is done in this area for the next release, PostgreSQL 12 as well. But already in PostgreSQL 11, we have several new types of partitioning. PostgreSQL 11 now supports hash partitioning. Previously, we only had list and range partitioning. And you can now have a default partition for either list or range partitions, which may be useful if you want to make sure that insertions of data into the table never fail, even if you haven't specifically created a partition that would naturally hold the new row. There's also been a good deal of work that has been done to make SQL features which were not available on partition tables in PostgreSQL 10 now work, or work at least with some limitations. So just to remind you, PostgreSQL 10 was the first version of PostgreSQL which supported partitioning. Again, we had a version of the partitioning feature in Advanced Server for some years prior to that, but partitioning only came into PostgreSQL in version 10, and there were a lot of SQL features that simply didn't work if you tried to do them on the partition table. You could do all of these things on the individual partitions, but that required a set of manual setup steps. And so in PostgreSQL 11, what you see is that now it's becoming possible to do more things on the partition table itself. So you can create indexes, for example, on the partition tables. You can create triggers on the partition tables. Another related change is that you can now update a row so that it moves from one partition to another. There are a few restrictions on that update capability in certain kinds of workloads that involve concurrent updates. But I think it's going to be a very powerful feature for a lot of people and really make partitioning much easier to use. And of course, the one that everybody really cares about is improved select performance. A great deal of work got done for PostgreSQL 11 on partition pruning. And as a result of that, queries that can benefit from partition pruning are significantly faster on PostgreSQL 11 than they were in previous versions, because the pruning can be done much more quickly than it could before. On the parallel query side of things, parallelism in PostgreSQL has now extended beyond parallel query per se, and the technology which Enterprise DB was involved in helping to create and get integrated into PostgreSQL is now being generalized by other people to work with other sorts of commands. And I think the most interesting change in this area is that some work has been done to allow parallel creation of B-tree indexes. Many of you may be familiar with the frustration of having to wait for a long time for a large new index to be created, and parallel index creation can allow those commands to run 2 or even 3 times faster than they did before. It doesn't scale perfectly. You can't make it 4 or 10 or 30 times faster, but still a 2 to 3x improvement in a single release is nothing to sneer at, and I think there's a lot to be happy about there. The queries that populate newly created relations can now be run in parallel, which was not previously possible. So if you create a new table using create table as, or if you create and populate a materialized view using the create materialized view command, the queries which are populating those will now make use of parallelism just as they would if you ran them as select queries. EDB was involved in providing a few more enhancements to the parallel query functionality as well. The parallel query handling for some union and union all cases has been significantly improved in PostgreSQL 11, and those changes benefit performance in some other cases as well. In addition to that, we did a very large project to add what I call real parallel hash joins to PostgreSQL 11. Hash joins were possible in earlier releases in PostgreSQL 10 and 9.6, but in those releases, the hash table had to be rebuilt separately by every worker process, which is obviously somewhat inefficient since you're doing the same work multiple times. The new hash join functionality eliminates that, and a single hash table is built cooperatively by all of the processes involved, and then all of those processes can probe that hash join, which is stored in dynamically allocated shared memory. There's better performance as well in PostgreSQL 11 for parallel sequential scans. Turning over to the advanced server side, we have a number of things which are really exciting, but probably the three most exciting things are data redaction, autonomous transactions, and a new performance diagnostics module called EDB wait states. Data redaction can really be thought of as a refinement of the permissions capabilities that we have had in previous releases, which have already allowed you to do things like set permissions on a database or on a table or on a schema or even on a column of a table or even on individual rows of a table. But now data redaction allows you to drive that permissions control all the way down inside the level of an individual value so that you can actually allow someone to see part of a value in a certain field, but not the whole of the value. So for example, if you have a credit card number stored in the database, you could redact everything except for what I've done on the slide here is the first 2 digits so that someone could see the type of the card without seeing the actual card number, or you could allow the last 4 through or anything else that you want. This functionality is actually very flexible and configurable. You can, by writing a very small stored procedure, specify exactly the portion of the value that you would like to be redacted and the way you would like it to be redacted and the portion that you would like to come through from the original version. Or if you don't want to write a tiny stored function to do that redaction for you, you can also use the Oracle compatible DBMS redact package, which we have added, which provides you with the same kinds of options that are provided in Oracle, and that is a wrapper around the core functionality, which we have added, which can also be used with familiar PostgreSQL style syntax. This feature also has a variety of options to support various security needs. This feature can actually be made quite secure, which I know is something that people tend to worry about with data redaction. Is it really going to protect my data? If you configure it properly and use it within the guidelines that we provide, then it will. But there are also less secure options for people who have needs that can't be satisfied by a configuration in which security is really locked down tight. We also have autonomous transactions in this release, and it's very simple to use. You just put pragma autonomous transaction into an SPL block, and it works. So there's really not much more to say about that than that. I'm very excited about this new EDB wait states capability, and I'll tell you about that on the next couple of slides. What the new EDB wait states module does is it makes a record of every wait state that it observes of every process in the system. So PostgreSQL for a couple of releases now has had a capability where in pgstat activity, when a backend is waiting, you can see the sort of thing for which it is waiting. And we can now sample those events and store them in such a way that you can query them later. Just as an example here, I ran a pgbench workload and I set up the configuration of the pgbench workload so that there would be a lot of processes trying to update the same tuples at the same time. And you can see from this report that I generated with this SQL query that in fact that's exactly what happened. There are a large number of locked tuple and locked transaction ID events here, which tell us that indeed this workload is contending not because of something particularly internal to PostgreSQL, but it's contending because of the nature of the workload which the user supplied, which is trying to have people update the same data at the same time, which no database system will be able to accommodate. We can actually drill down into this a little bit more on the next slide. And what I've done here is I've taken the same statistics which I showed you on the previous slide, and I've broken them down by which specific query actually caused any particular wait event. And in this slide, the query has been abbreviated. That's just so that it fits on the slide. Actually, the whole query is available in the database, and I just wrote some SQL logic to redact that a bit so that it would be easy to view here. But if you look here, what you can see is that the lock transaction ID and lock tuple events are actually coming from the pgbench branches and pgbench tellers table. And there's actually very, very little contention on the pgbench accounts table. So this feature is not only capable of telling you the kind of problem that you have, but by looking at the particular SQL queries which you have available, which you have been running in your database, you can actually see on a per query basis which queries are causing the specific performance problems that you're facing. And we hope that will be useful to you in understanding better how you can improve the performance of the system.
Great.
There are a few other changes as well, which I'll just mention very briefly. We have changed our version string format. We did not just want to copy the PostgreSQL version string format because it is a modified version of PostgreSQL. It is not pure PostgreSQL. But we did want to avoid the problem that many tools which are perfectly compatible with Advanced Server actually see Enterprise DB in the version string, and then they just decide that they don't support this. And they move on. So the text of the slide here shows you what the new version string format looks like, and we hope that that will not be confusing to anybody, but will make tools work that were previously refusing to work for actually no very good reason. We have a new option in our EDB filter log module, which you can use to redact password commands. So if you're concerned about someone typing an alter user command to change their password and have their password show up in the system log, this command will help you. We've got some performance enhancements in our Oracle connector, particularly against wide tables where you select a subset of the columns. Those queries run much faster now. And we used to have for many years a schema called DBO, which was pre-installed, and that caused conflicts with some users who wanted to use a schema by that name for their own purposes. We didn't have a whole lot of stuff in our DBO schema, so we no longer install that by default. We still have the same views that schema held before available as an optional feature if you'd like to install it, but by default it's out of the way so that it won't cause you any trouble if you happen to be using that name yourself.
All right, thank you very much. Thanks, Robert. I'll hand it over to Dave to tell us about Postgres Enterprise Manager 7.5 and what's new in that world.
Thank you, Mark. Thank you, Robert. So Postgres Enterprise Manager is designed as a tool for managing, monitoring, and pretty much doing anything you need to do with your Postgres and EDB Advanced Server installations. I'm going to go through a few of the features first of all, and then we'll look at a couple of the new features that were added in the over the last few releases, the last year or so. And then finally, I'll give a quick demo of one of the new features that actually comes from PGAdmin, on which PEM is based. So PEM has built into it what we call probes, which are about, well, there's exactly 60, I think, at the moment. And each probe collects some amount of data about your Postgres installations or the operating system that it's running on. So PEM will actually collect something like 400 different metrics about your Postgres server, its replication, the table statistics, the memory used in the server, and so on and so forth. As far as I'm aware, that makes it the most comprehensive out-of-the-box monitoring system for Postgres systems. Next slide, please. So once we have that data, we obviously need something to do with it. So the first thing we want to do is allow you to create alerts on it. So we have nearly 240 predefined templates for alerts. Those will monitor the metrics that are collected, and you can define threshold levels that specify whether or not a value that's being seen is okay, is a low-level alert, medium-level, or high-level alert. And we offer a number of different ways of reporting that information. Obviously, you can view it within the application itself. You can have it reported to an upstream management system via SNMP. We can integrate with Nagios, or we can send you emails if that's that's the way you like to get alerted. Next slide, please. In addition to the predefined metrics, probes, and alerts, we do allow you also to create your own. So probes can have various different collection methods. They can be a SQL query. If you're running on Windows, it can use the Windows management interface, or it can be a batch or a shell script that returns some value from the system. Now, the nice thing here is that it actually allows you to create and add domain-specific statistics to the system. So if you want to monitor something specific to your application, you can very easily write a probe to do exactly that. And you get the same functionality with those custom probes as you do with the ones that are built in. Next slide, please. Once you've got that data in there, obviously you can create the alerts, as we said earlier. You can also use pre-built dashboards that allow you to browse that information, or create your own dashboards with either standard charts or custom charts and graphs. In addition to allowing you to create standard charts that you can use, we have a tool called the Capacity Manager that allows you to create predictive charts that can then be imported into the dashboards. The predictive charts allow you to create reports that say things along the lines of, show me when this storage system is going to hit 90% usage based on the current usage rate. And that can be very handy for predictive reporting and detecting issues as they come up. The alerts that we mentioned earlier, again, we can send those via email, SNMP, integrate with Nagios. Very configurable system. You can have different email groups, for example. So you could have all the low-level alerts go to the intern. You can have the high-level alerts go to the SVP and so on. And define your group not just according to seniority or what team you want to deal with them, but also based on time blocks. So, for example, you might have people working different shifts. So you can have the DBA A team, DBA B team, DBA C team, all of whom will receive alerts at different times of the day as appropriate. You can also run scripts on receipt of an alert. So if you can write a shell script, for example, that will run on either the PEM server or on the server that's being monitored, that will take some action when an alert is received. That might be to try and restart a service, for example, or it might be to write a log file or try and capture some additional information about the state of the system. Next slide, please. In addition to monitoring Postgres and Advanced Server, we can also now monitor and manage EDB Arc, which is our cloud deployment engine for Postgres that allows you to deploy clusters of Postgres servers on the fly in cloud environments. So PEM now gives you a full management interface for multiple Arc servers. So if you could be running Arc in AWS and Azure, for example, and connect to both of those systems, monitor them, manage them, all from the one console. In addition, Mark was talking earlier about EDB Failover Manager, which PEM is also able to manage and monitor for you. Next slide, please. We have various wizards built into PEM that are there to help with day-to-day tasks. So, for example, this is a screenshot from the tuning wizard, which helps you define a sort of baseline tuning for a server. And suggest what changes you might need to make based on the workload type that you describe and the configuration of the system in terms of memory and so on. There are other wizards to help with tasks such as configuration of logging and auditing. They allow you to configure the options globally across all your servers. And then in the case of those two particular wizards, actually allow you to configure PEM to collect the log output from all of your servers, so you've got it centrally where you can monitor it and search it. Slide, thank you. The SQL Profiler is a very useful add-on tool for PostgreSQL and Advanced Server. With the aid of a plugin in the database server, this allows you to take a real-time snapshot of the activity that happens through the Postgres server. So you start recording data. Every single query that is executed will get recorded in a log, along with numerous different statistics. You can then stop recording and go back and browse through that data. You can look at the individual queries and all the stats associated with them, look at the query plans and so on. But perhaps more importantly, you can also look at various different aggregate statistics. So you can say that, for example, this particular query string ran 23 times during my sample period and was responsible for 56% of the writes to disk. So that can be very helpful in performance diagnostics and understanding how your application is behaving on your server. Next slide, please. Now, coming in Postgres 7.6 to complement the EDB wait states module that Robert was just talking about, we'll also have performance diagnostics module in PEM. This will allow you to connect to the database server, and instead of running the queries that Robert showed you, specify a time period, and then it'll show you a highlight, as you can see in the screenshot, of the activity at the top during that time period. You can then use the little blue window, which is adjustable width and adjustable position, to focus in on a particular area. In the graph below, it will then show you for that time period the various different wait states that were encountered. And then you can actually use the section at the bottom of the screen to start to analyze that information and understand the different weights that were caused by the different queries and so on. You can then pivot that round, look at it from the perspective of different weight types or different users or the SQL query. And you can drill down further, and once you've chosen a particular query, for example, start to dive into a second level dashboard that lets you analyze in depth what weights that query caused while it was executing, or what it had to wait for while it was executing. Okay, next slide, please. So as I mentioned at the beginning, PEM is based on PGAdmin 4, which is a community open source project, which provides a sort of real-time management interface for Postgres. This allows you to connect to the database, browse through all the objects, create tables, functions, and so on, run arbitrary SQL queries, and do some very basic real-time monitoring of the system. EDB is the biggest contributor to PGAdmin 4. We started the project a couple of years ago as a complete rewrite of the original PGAdmin, and have been contributing significantly ever since and continue to do so. So as part of Postgres Enterprise Manager, you get all the functionality of PGAdmin built in. So not only can you monitor everything, but you can also connect to your servers, you can run queries, and so on and so forth. Next slide, please. Okay, so very quickly going to run through just a couple of new features that we've added. So for some time, we've had what we call team support in PEM. Team support was designed as a way to allow larger organizations to hide and show different servers to different users. So for example, you might have somebody on the development team who could see all the development servers, and somebody on the HR team who could just see the servers they were responsible for maintaining for the HR department, and so on. That was really a convenience feature. Users could still dig in and see the underlying data if they wanted in in the PEM database. So they collected stats about the other servers and so on. Starting with PEM 7.2, which was released earlier this year, we've actually fully integrated the team support with row-level security in Postgres. And what that means is you can now actually use this as a security feature. Have one PEM that's being used to monitor PEM servers from lots of different teams and departments, and be confident that somebody who doesn't have access to view a particular group of servers could not only not see them in the user interface, but they can't get to the underlying data in the database either. The team support is very, very flexible. It actually uses Postgres roles, so you can link a PEM agent or a Postgres or EDB Advanced Server to a role or a team, as we call them. And then any user who is a member of that role will be able to see those agents and servers that are linked to that team. Next slide, please. So one of the other new features that we've added this year, again, another security feature, is role-based access controls. Prior to PEM 7.2, users were either admins or read-only. So it was kind of, you're the system administrator or you're the manager who we don't want to go in and break anything, but does need to see reports. With PEM 7.2, we've added role-based access controls. So you can now specify in a completely configurable way, you can define groups, again, based on the underlying Postgres roles, which have membership in other roles. So there may be a role, for example, that allows you use of the capacity manager tool. So anyone who is granted that role, either directly or through membership in another role, can then use that tool. And what this gives us is complete flexibility. So you can set up the system exactly as you want to allow a specific group of people access to these three tools, and a different group of people access to everything, and another group of people access to another different two sets of tools, for example. Basically giving you the freedom to set up things exactly as you want and as you need in your organization. Right, I have time for a very quick demo now. I need Mark, who I think is the presenter at the moment, to hand over control to me so I can do this one. I mentioned when we looked at the PGAdmin slide earlier that EDB is one of the biggest contributors to PGAdmin. All those features we get the benefit of in PEM. Now, as part of the community leadership, if you like, for the PGAdmin project, one of my responsibilities has been helping community members contribute to the project as well. And one feature that we had added recently was from a Google Summer of Code student who spent time working on the project. And we worked closely together to get this to come to fruition. So what I've got here on the left-hand side, you can see I've got a database open. I've got a number of different tables in there. Now, this is actually a spatial database. It's got the PostGIS extensions installed, which allow us to store geospatial information. I can select that table and then click on the button at the top here to run a query. So this is going to allow me, if you're familiar with PGAdmin and you're familiar with PEM, I've opened this up now in edit mode. So effectively I could edit any of the data here and save the results. But one of the things that you may notice is that we've now got a new button that's appeared here. This geometry column contains a GIS geometry field, which is something that we can render. So by clicking here, I can actually see a map where each one of these dots represents a city or from one of those rows in that table. So for example, that one there is called GAT. I suspect I shall probably never go there in my life. But what we've got here is the ability to render the GIS information and overlay it onto a map. As you can probably guess from my accent, I'm from the UK, very close to Oxford right now. We have a number of different maps, so you can just render on a blank background if you want. Look at topography maps, different styles and so on. And there's further work underway to allow those to be configurable. So if you've got access to different map sources, you would be able to add those into the system as well and view the data overlaid on those. The default is the street map, which is just from the OpenStreetMap project. So you can obviously zoom in all the way there and see very, very detailed maps. Another very quick example, we can look at country outlines. So again, I can query that data. I've got 3 geometry columns here that are of different types. This first one is one of the types that it knows it can render as a map. And in this example, as you can see, we've got the outlines of the different countries just overlaid on the map there. And the information that's shown in this pop-up is basically the other fields in the table. Okay, so that was the quick demo that I wanted to show you there. If I can just transfer control back to Mark.
Okay, so Dave, just walk us through the platforms and what's coming next.
Yeah, so the EDB Postgres platform version 11 is going to support the following platforms: 64-bit Windows, production support on server versions. Obviously, we don't expect people to be running production systems on Windows 10, but obviously it is useful for development and so on. RPM distributions supporting CentOS, RHEL, and OEL 6 and 7 on 64-bit Intel. CentOS and RHEL 7 support on PPC 64LE. That's IBM Power 8 and Power 9. SLES 12 support as well on Intel 64-bit with SLES 15. Not entirely sure when that's going to be ready yet, but I would expect it to be within Q1. Debian support, which is expected to be ready in January. We'll be supporting Debian Stretch with on Intel and Ubuntu 18.04. Both of those using Debian native packages rather than installers. Next slide, please. We're also supporting container distributions. The update for the platform version 11 will be out is due in February. That'll obviously support EPAS 11. It'll also support PEM 7.6. So we'll have the performance diagnostics in there. Amongst some of the things we've added, just very quickly there, stateful set support, which allow you to take advantage of the persistent storage that you get with stateful sets. We'll also be providing some example Helm charts, which we've not provided in the past. And that will support OpenShift, Kubernetes, and Docker platforms. And that's it from me. Thank you.
All right, thank you very much, Mark, Robert, and Dave. We have a few questions here. I think maybe we'll be able to answer one or two, and otherwise we will follow up with anyone's whose question was not answered following the presentation. The first question is, what is the difference between your Postgres and Greenplum?
Robert, you want to take that one?
I can try. I think Greenplum is more aimed at kind of large analytic types of workloads, and our advanced server is really aimed at we say enterprise workloads. We're looking at migration. We're looking at, and we're also looking at providing a complete set of tooling around the database, rather than being focused on providing, as I say, a sort of very large scale analytics solution, which I think is what Greenplum is targeting.
Great, thank you, Robert. This question relates to PEM. Is this profile a new feature, and is PEM an advanced server only tool?
So the SQL profiler is not new. The SQL profiler has been in there since the very first version of PEM. The new interesting feature as far as diagnostics is concerned is the performance diagnostics tool that works with the EDB wait states. The SQL profiler will work with PostgreSQL or EDB Advanced Server. Performance diagnostics will only work with EDB Advanced Server. And PEM is available with either our standard subscription, I believe, or our enterprise level subscription.
All right. Thank you, Dave. It looks like we are at the top of the hour. I apologize for those questions that we were unable to get to today, but that is all the time that we have. I'd like to thank everyone very much for joining the webinar. And as I mentioned, I'll be sharing the recording along with the slides with you this week. Thanks very much, and I hope you have a great rest of your day. Take care.